Okay. Let me adjust the microphone real quick. Okay. Let's open up MonDevelop. Oops. Now, this is better. The quality of this microphone is pretty good. So, I'm guessing that if I have to adjust the volume after the recording is done, it will be fine. So this is the new CTFE evaluator I'm working on, and this is well, now you can have the over-the-shoulder perspective if you want that. If you don't want that, that's fine too. But then you wouldn't be watching this stream, which is all about code. Okay. Hello, my name is Stefan Koch, and I am going to code this CTFE evaluator here, and let me show you why it's needed. Oops. I guess I can make the font a bit bigger here. Let's take isn't there like a console font? Liberation mono space 13 maybe. Okay. Now this is still not great. Oh, this was just for the front thing. Liberation mono. Yeah, that's definitely big enough for everyone to read. So, hello, my name is Stefan Koch. Hello, my name is Stefan Koch, and I'm going to show you the process of coding a CTFE evaluator. And you will be learning a bit about DMT and about bytecode and interpretation and CPU architecture and all this stuff, right? And I hope you enjoyed. So first, let me show you why we need a new devaluator. Yeah, well, clear. Okay. Hello, my name is Stefan Koch, and I'm going to show you, or rather, you are going to be right there when I am coding this CTFE evaluator. Well, not right there because I still wasn't able to get OBS to run on this Ubuntu thingy here. But almost right there, right? So, with that, let's get started. First, let me show you why we need a new CTFE evaluator. So, I have a simple test here. Right? Well, this test doesn't really show how slow CTFE evaluation is, but let me show you another test. Actually, this is code from a bug report from bug 6498. And you can see here, this is all the code it has. It counts up a variable, compares if it is the same as the argument. If it is, it returns, and if it is not, it counts up. So this loop does absolutely nothing. And in this program message here, it does quite often, quite a lot, nothing. And let's see how long this takes to compile, right? Do time dmd source bug d, and we wait and wait and wait, and there's the result. And it took 11 seconds to execute that loop that does virtually nothing. Now, let's compare that to the time a native evaluation takes. Like, not the evaluation at CTFE. And we comment out this program message because otherwise the compiler is going to take super long again. So this stopwatch here counts how many microseconds this takes. And we are using the same argument as we did in the program message there, which took 11 seconds if I recall correctly. So let's do the same. Now we just compile it. And this will create an executable called bug. And we do time./bug. And it takes no time at all, like 34 milliseconds. It takes like nothing. Okay. Now, let me build my version. And I hope this build works. And the build will be in source.dmd. And note that this is a debug build, so it will have a lot of debug output. But first, let me show you this thing. Okay? I just commented the line in that took 11 seconds with the standard DMD, and now with my modified version it takes it throws an error, of course. Let me fix this one really quick. Let's just comment out everything that doesn't have anything to do with it. And compile again. And whoa, we are just finished. Let's do the time command on it. And it takes less than a second. We just went from more than 10 seconds to less than a second for the same stuff. Okay. Let's try to take it up a notch. Now we execute the loop. What is this? Million? Something like that. Now we execute it 1,000,000 times. So one order of magnitude more. Yeah, and now it takes a while. The debug output will even tell you how long it took. You can see now it took 4 seconds. And we can see how much of that was due to evaluating the bytecode. So 500 microseconds is the time it took to build the bytecode, and 5,000 microseconds is the time it took to execute it. And I had much better timings before, so I have an idea what caused it. Let's go into here, and this thing here is this is a visitor that generates the bytecode, and it is responsible for for generating bytecode. Have to add this out, I guess. Yeah. When we this code here, whoops, just calls out to the bytecode generator and the bytecode interpreter, which is in this file. And it does some stuff when it comes to evaluating expressions, and it's this. It sets condition flags, and those condition flags were meant to speed up things, but in reality they clearly don't. So let's see what we can do about this. So all those condition flags have this if, right? Oops. When we search for that and search and replace. Oops. When we search for that and search and replace. Then we find it just once? Why just once? Because it definitely happens multiple times. It happens up there. And the code doesn't look that different. Really? I just have one match when I look for that, and I have none when I look for that. Um, um, yeah, I thought it was going to be easy to just do a search and replace, but it seems like that is not the case. Um, Perhaps I can replace just that line. Oh yes, I can replace just that line. And instead of using condition flags, I'm going to use just one condition because the way the current code is structured, it will just be able to evaluate one condition at once, so it won't do any difference to the code. And let's just replace this by cont equals true. Or you know what? We can replace this by simple assignment. We can say cont equals this. And we can do that with all the others. As well. And cont is the one condition we keep track of. So let's do this. And I like to add optional braces when I'm working with pointers, just so I know that I'm not accidentally comparing against the pointer value or having some stuff happening there. I know for someone who writes compilers, I should really know the order of evaluation and the operator precedence, but it's true. Sometimes I make mistakes in that regard, and if I can eliminate those mistakes by making stuff explicit, why not? I mean, I have to be a smarter guy to be able to remember all the precedence rules from C correctly. Perhaps it's not that big a deal, but yeah. This was the conditional jump files if the condition is not true. So if the condition is not true, we set the instruction putter, and I think that took care of every cont flags. That took care of the condition flags business, I think. So let's rebuild and retry. And we made some mistake in line 1269. Probably 1269. Where is it? Oh yeah, we missed the semicolon, and the syntax highlighting here nicely told us.